Hello everyone, today I'm going to teach you how to work with robust standard errors for final regression with cross-sectional dependence. First of all, we need to understand what is cross-sectional dependence. Cross-sectional dependence means that a bucket of data is correlated. For example, let's imagine Canada, United States, and Mexico. It's unbelievable think that the countries are not correlated. Why? Because these countries are near, the countries trade a lot, Canada and United States speak the same language. So, for many reasons, the countries can be correlated. Other example is European Union. Obviously, the countries are correlated because they are linked by constitutions. So it's hard to believe that are not correlated. But in the most part of investigations, it's not taking account this correlation or cross-sectional or spatial dependence. So today I'm going to teach you how to work with cross-sectional dependence. In this case, first of all, I have this model or a simple model of fixed effects. The pollution is explained by GDP, population density, it's depend on regulation, education, and consumption of energy. Our model have problems of cross-sectional dependence, heteroskedasticity, and autocorrelation or first order. Okay, our model has a lot of problems, but fortunately we have three methods for solve these three problems in easy way. Eh, let's start with the first one is feasible generalized least squares. The command is HTGLS panels correlated autocorrelation of order 1. Aquí, here we have a feasible generalized least squared, FGLS. He would declare that our panel is correlated and have autocorrelation of order 1. And he will have panels are heteroskedasticity with cross-sectional correlation and common autocorrelation of third order. Okay, we solve the problem. But we have another problem. Why? Because to these panels need to be a period of time in enough large. For example, let's imagine that I study in 15 countries of European Union. Here, our period of time should be bigger. For example, 30 years. In this case, this method is correct. Or for example, we have 50 years and 10 countries of Africa. The method is correct. But if we have 50 states of United States and 10 years of period of study, this method FGLS it's not the best option for estimates. Okay? When this happens, we have another option that is the panel corrector standard error. We delete this part and only add correlation of type 1. Aquí we have panels corrector standard errors. In this case, it don't mention, but if you read the paper of Becky Katz, they develop this method PCSE, says that when you solve the problem uh, of a panel is correlated, automatically solve the problem of heteroskedasticity. So in this case, we have this estimation that is very similar, but it's different because you can use a panel when n is bigger than t or is equal in true. Okay, for final we have another panel that is other way of estimate the panel that is Driscoll and Kraay standard errors or the key. Okay, in this case we have two options: fix the effect, and if we don't add nothing, pollet only yes. But we are working on fix effect. As you can see, it's similar. It's this way. It's the similar. It's the same coefficients of fixed effect. As you can see, and you are asking what is the difference. This part, the p-value and the confidence interval, as you can see, change because decay method taking account heteroskedasticity, autocorrelated, and cross-sectional dependence. We can modify the number of lags with this command. By default is 2, but you can use 1, 3, the autocorrelation that you consider. As you can see, this the p-value are changing. Okay, so to recapitulate, we have these three easy methods to solve heteroskedasticity, cross-sectional dependence, and autocorrelation. But a warning is that feasible generalized least squares you need to have a period of time bigger than the subjects of your panels. In the case of panel correlated standard errors, you can use when the subjects are bigger than the period of time or equal. And this Kraay method you can use it in every circumstance. And what of these methods is the best? According to Driscoll and Kraay, that is the most recent method, their method is better. It's semi-equal to the panel corrected standard errors, but under certain circumstances, this method estimates better. Why? Because this is a no parametric method. So it's hard to understand the mathematics behind the Driscoll and Kraay method, but in some cases this is the best method. The second method I consider that is panel corrected standard errors, and the third method feasible generalized least squares because it's the oldest method. Is for example in the paper of Becky Katz they explain that feasible generalized least squares sometimes have overconfidence, so they prefer the methods. So okay, recapitulate. We use these methods when we have these problems and you need to test, and these methods solve it. Okay, that's all for today.